In this second part of gamma function, we will study how to evaluate integrals using definition of gamma function and the properties of gamma function. So before we move on, let us revise a few basic things. First, definition of gamma function, which is gamma n equals integral from 0 to infinity of e raised to minus x into x raised to n minus 1 dx. Then the properties of gamma function, the first being gamma n plus 1 is n gamma n, same as n factorial, and gamma n is n minus 1 gamma n minus 1 equals n minus 1 factorial, and this n factorial is also equal to integral from 0 to infinity of e raised to minus x into x raised to n instead of this n minus 1 dx. Now with the help of these definitions of gamma function and these properties, we will see how we can evaluate the integrals. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. Before we solve the next example, let us get acquainted with one more result of gamma function, which is gamma half is square root of pi. We will prove this result when we will study beta function. So our next integral is from 0 to infinity of e raised to minus x into x raised to minus half dx. According to property, it will be gamma minus half plus 1, that will be gamma half, which is square root of pi. Next integral is from 0 to infinity of e raised to minus x into x raised to 3 by 2 dx. Here we have chosen power of x to be a positive fraction, which according to the property will be gamma 3 by 2 plus 1, that will be gamma 5 by 2, which again by property will be 5 by 2 minus 1 gamma 5 by 2 minus 1, which will be 3 by 2 gamma 3 by 2. This will be 3 by 2 into, now for this gamma 3 by 2 we will write 3 by 2 minus 1 into gamma 3 by 2 minus 1. This will be 3 by 2 into half gamma half, that will be 3 by 4 square root of pi, because gamma half is square root of pi. What will be integral from 0 to infinity of e raised to minus x square dx? According to property, this will be gamma of this 2 plus 1 gamma 3, but gamma 3 is 3 minus 1 factorial, 2 factorial, which is 2. What will be integral from 0 to infinity of e raised to minus x cube dx? It will be gamma of this 3 plus 1 gamma 4, but gamma 4 is 4 minus 1 factorial, 3 factorial, which will be 3 into 2 into 1, 6. What will be integral from 0 to infinity e raised to minus x raised to 4 dx, which we can directly write this 4 factorial, which is 4 into 3 into 2 into 1, which will be 24. We will evaluate integral from 0 to infinity of e raised to minus x raised to 4 dx. Now this integral does not look like integral of gamma function, but it can be converted into the definition of gamma function by substituting this x raised to 4 equals t. So we will substitute x raised to 4 equals t. X will be 1/4 power of t. After differentiation, we get dx equals 1/4 t raised to 1/4 minus 1 dt. That will be 1/4 t raised to minus 3 by 4 dt. So we will use this value of dx, which is 1/4 t raised to minus 3 by 4 dt for this dx. So our integral becomes integral from 0 to infinity of e raised to minus x raised to 4 will become e raised to minus t as per this substitution. And for this dx we will use this 1/4 t raised to minus 3 by 4 dt, which will be this 1/4 integral from 0 to infinity of e raised to minus t raised to minus 3 by 4 dt. You will observe that the original integral in x has been converted into a new integral in t, which is as per the definition of gamma function. So this we will write further as 1/4 gamma 1 plus this n, which is minus 3 by 4, which will be 1/4 gamma 1/4. So the value of this integral will be 1/4 gamma 1/4. Next, we evaluate integral from 0 to infinity of e raised to minus x square by 4 dx. As usual, we will substitute for this x square by 4 equals t, so that x square will be 4t and x square root of 4t, that will be 2 t raised to half. Now we will differentiate this. It will be dx equals 2 into half t raised to half minus 1 dt, that will be, after cancelling these two, t raised to minus half dt. So we have got here dx equals t raised to minus half dt, that we will use for this dx. So our integral will become integral from 0 to infinity of e raised to minus t after substituting for x square by 4 t here, and in place of this dx we will substitute this t raised to minus half dt. We observe that original integral, which was in terms of x, now has been converted in terms of t. This will be, according to properties, gamma of this minus half plus 1, which is gamma half, and as we know, this is square root pi. Next integral is integral from 0 to infinity of square root of x into e raised to minus cube root of x dx. First we will rewrite this integral as integral from 0 to infinity of x raised to half into e raised to minus x raised to 1/3 dx. Now as usual we will substitute for this x raised to 1/3 equals t, so that x will be t cube. We will differentiate this dx equals 3t square dt. Now we will rewrite this integral I equals integral from 0 to infinity of, in place of this x we will use t cube, so it will be t cube raised to half into e raised to minus, for this x raised to 1/3 there will be t, and for this dx we will use this 3t square dt. So it will be this 3 integral from 0 to infinity. First we will write this e raised to minus t, then this t raised to 3 by 2 into this t square dt. This will be further 3 integral from 0 to infinity of e raised to minus t into t raised to 3 by 2 plus 2 dt, which will be 3 integral from 0 to infinity e raised to minus t into t raised to 7 by 2 dt. This will be 3, and according to definition of gamma function, this will be gamma 7 by 2 plus 1, which will be 3 gamma 9 by 2. Now applying property of a gamma function on this gamma 9 by 2 successively, this will be 3 by applying property of gamma function on this gamma 9 by 2. It will be 9 by 2 minus 1, 7 by 2, gamma 7 by 2. That will be 3 into 7 by 2 into 7 by 2 minus 1, 5 by 2, gamma 7 by 2 minus 1, 5 by 2, which will be 3 into 7 by 2 into 5 by 2 into gamma 5 by 2 will be 5 by 2 minus 1, 3 by 2 into gamma 3 by 2. It will be 3 into 7 by 2 into 5 by 2 into 3 by 2 into gamma 3 by 2 will be 3 by 2 minus 1 half into gamma half, which finally will be product of all these numbers 315 upon 16, and this gamma half will be square root pi. So this will be the value of the integral 315 by 16 square root of pi. Let us solve an integral involving trigonometric functions. Integral from 0 to pi by 2 of 4th root of tan theta into e raised to minus square root of tan theta into sec square theta d theta. We know that derivative of tan theta is sec square theta, so we will substitute tan theta equals t, so that after differentiation it will be sec square theta d theta equals dt. In this substitution, when theta is this 0, tan 0 will be t, but tan 0 is 0, so t will be 0. Secondly, when theta is this pi by 2, tan pi by 2 is infinity, t will be infinity. So for this integral I, the new limits of integration will be from this 0 to infinity 4th root of tan theta is t into e raised to minus root t, and for this sec square theta d theta we will write dt. Rewriting this, integral from 0 to infinity of t raised to 1/4 into e raised to minus t raised to half dt. Thus we will rewrite integral from 0 to infinity t raised to 1/4, we write t raised to half into e raised to minus t raised to half dt. Now in order to solve this integral, we will substitute this t raised to half equals x, so that t will be x square, and after differentiation dt will be 2x dx. So this integral I becomes integral from 0 to infinity is x, so x raised to half into e raised to minus t raised to half, but t raised to half is x, so it will be minus x, and dt is 2x dx. This we can rewrite as this 2 integral from 0 to infinity e raised to minus x into this x raised to half into x will be x raised to half plus 1, 3 by 2, and this dx. So now this integral in t has been converted into integral in x. This will be 2, and this, according to property of gamma function, gamma this 3 by 2 plus 1, which will be 2 times gamma 5 by 2. We will apply the property of gamma n on this gamma 5 by 2 successively. That will give 2 into 5 by 2 minus 1, 3 by 2, gamma 3 by 2. That will be 2 into 3 by 2 into 3 by 2 minus 1 into gamma half. Cancelling these two, we get 3 by 2, and for gamma half we have square root of pi. So the value of this integral will be 3 by 2 root pi. Next we have to evaluate integral from infinity to 0 e raised to minus 1 by x cube into x raised to minus 4 dx. As usual, we will substitute for this 1 by x cube t, so x raised to minus 3 will be t, x will be t raised to minus 1/3. After differentiating this, we will get dx equals minus 1 upon 3 t raised to minus 1 upon 3 minus 1 dt. That will be minus 1 upon 3 t raised to minus 4 upon 3 dt. So we got substitution for dx. Now the integral turns into integral from infinity to 0 e raised to minus t. Since x is t raised to minus 1 upon 3, x raised to minus 4 will be t raised to 4 by 3, and dx will be this part, which is minus 1 upon 3 t raised to minus 4 by 3 dt. Now because of this negative sign, we will reverse the limits and write 1 by 3 integral. Instead of infinity to 0, we will write 0 to infinity e raised to minus t raised to 4 by 3 into t raised to minus 4 by 3 will be 1, which we write as t raised to 0 dt. This will be 1/3, and this integral according to definition of gamma function will be gamma 0 plus 1, that is 1/3 gamma 1. So the integral will be 1/3 into 1 because gamma 1 is 1. So this is the value of the integral. Now the examples that we are going to solve hereafter, we will not solve them completely, but we will only learn the specific ideas that need to be used in those examples. The first being integral 0 to infinity of e raised to minus 1 by x raised to 4 dx. Here, by substituting 1 by x equals t, we can solve it further and get gamma 3, which by properties of gamma function will be 2 factorial, and the answer will be 2. Next example is integral from 0 to infinity of x e raised to minus x raised to 6 dx into integral from 0 to infinity of x square e raised to minus x raised to 4 dx. Here, in this first integral, we will assume this x raised to 6 equals t, and in this second integral I2, we will assume this x raised to 4 equals t. Solve them separately, where we get this I1 1/8 gamma 1/4 and this I2 1/4 gamma 3 by 4. So the product I1 into I2 will be 1 by 32 gamma 1/4 into gamma 3/4. Now we have a result for this gamma 1/4 into gamma 3 by 4, which goes like this: gamma 1/4 into gamma 3/4 is square root 2 pi. We will prove this result later on. Hence, I1 into I2 will be 1 by 32 into root 2 pi, that is root 2 pi by 32. In the next example, we have to find integral from 0 to infinity of x raised to minus half e raised to minus x cube dx into integral from 0 to infinity of x raised to 4 e raised to minus x raised to 6 dx. By usual substitution, this x cube equals t and this x raised to 6 equals t. We will solve these two integrals I1 and I2, and the first integral I1 works out to be 1 by 3 gamma 1 by 6, whereas the second integral I2 works out to be 1 by 6 gamma 5 by 6, and the final integral I will be I1 into I2, which will be 1 by 18 gamma 1 by 6 into gamma 5 by 6. We have a result for this gamma 1 by 6 into gamma 5 by 6, which goes like this: gamma 1 by 6 into gamma 5 by 6 is 2 pi, which we will prove later on in beta functions. So this integral I will be 1 by 18 into 2 pi, that is pi by 9. If you like this video, please like it, share it, and subscribe to this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.